So today we will start what are the factors affecting workability. Before that, I want to continue what are the previous topics we have studied regarding workability. We have studied concrete, what are the factors affecting concrete, ingredients of concrete, and segregation, bleeding, grades of concrete, and workability, and what are the tests that are used to find out workability. Then we come upon our topic that are what are the factors that affect workability. So the workability is a property which is associated with fresh concrete. It depends on the materials and mixture of portion, and it also majorly depend on environmental condition. So the first most important factor that affect workability is water content. As we all know that we have to decide water cement ratio before mixing a concrete mix, before deciding a grade of concrete. So the water cement ratio in itself determines the basic properties of the cement paste and requirement of workability, such that there should be enough cement paste to surround the aggregate particles as well as to fill the voids in the aggregates. So the higher the water content, the higher will be the fluidity of concrete, so that we improve our workability of a mix. Second, the utmost important property of factors affecting workability is ratio of coarse and fine aggregate. So once the water content in the mix is fixed, there is some relation between the water cement ratio and grading of the aggregates. Grading means you have to decide the aggregate size so that the void should be minimum. So if the void should be minimum, then we have enough paste to coat the aggregates and to fill the voids. So it is seen in practice that there would be one optimum combination of coarse and fine aggregate, resulting in highest workability for a given water cement ratio. So mix with higher water cement ratio would require somewhat fine grading, and for mixes with lower water cement ratio, inversely proportional, that is coarser grading is preferable. The next point that affects the workability is aggregate cement ratio. So aggregate cement ratio is the most important factor influencing the workability. The higher the aggregate cement ratio, so the leaner is the concrete. It means in lean concrete, less quantity of cement paste is available for providing lubrication as well as for coating the surface of aggregate as well as for filling the voids. On the other hand, if we take lower aggregate cement ratio, we can produce rich concrete so that more cement paste is available for making a mix cohesive and fatty to give better workability. Another point that affect is influence of aggregate properties. So aggregate properties means what is the shape of the aggregate, what should be its size, surface texture, fineness or grading. So for same volume of aggregates in the concrete, use of coarse aggregates of larger size and preferably its shape should be rounded gives higher workability because of reduction in total specific surface area and its particle interference. So if the aggregate should be rounded, then there should be minimum friction between them, so particle interference will be less. And if we use flaky or elongated aggregates, flaky elongated means chapta or lamba aggregate, results in lower workability primarily because of increase in particle interference. Interference means friction. Then second important point is the use of fine sand with corresponding increase in specific surface area. So if we use finer sand, then it will demand more water, so for the same water content workability decreases. For this I can give one example. अगर हम आटा सानते हैं और मैदा सानते हैं, तो आटे के कंपेरेटिवली हमको मैदे में ज़्यादा पानी चाहिए, इसलिए क्योंकि उसका स्पेसिफिक सरफेस एरिया ज़्यादा है. सो सेम एग्जांपल कैन बी पुट हियर. इफ द सैंड इज वेरी कोर्स, द नेट इफेक्ट ऑन वर्केबिलिटी इज increase in particle interference, decreases in specific surface area. Then because of the greater contribution So next point is, because of the greater contribution of the total specific surface area, the grading of the fine aggregate is more critical than grading of coarser aggregate. So the proportion of fine to coarse aggregate should be so chosen as neither to increase the total specific surface area nor to increase the particle interference in fine aggregate. Then next, influence of time and temperature. As we mix a concrete, fresh concrete loses workability with time, mainly because of loss of moisture due to the humidity and evaporation. Part of mixing water is absorbed by the surface of aggregate, or it is lost by evaporation in the presence of sun and wind, and part of it is consumed in the chemical reaction of hydration of cement. On an average, if a 12 centimeter slump concrete may lose about 5 centimeter slump in first 1 hour, that is major problem. Then compressive strength, a major property of concrete. So whenever you use a concrete mix for a structure, first of all we have to find out its compressive strength. The compressive strength of hardened concrete is considered to be the most important. It can be measured easily by a standard size cube, that is 150 mm, or a cylindrical specimen. So the factors that affect the compressive strength of concrete are: first, water cement ratio, degree of compaction, and the age at the time of testing. Second, aggregate cement ratio. Third, cement content characteristics. Fourth, influence of strength of cement on strength of concrete. Then fifth, the effect of placing and curing. Then how we determine the compressive strength of concrete? It is determined in lab by making a specimen of 150 mm cube size. We decide a grade of concrete. For example, if we decide M20 grade of concrete, then we have to take a proportion 1 and a half and 3, that is 1 is cement, 1.5 is fine aggregate, and 3 is coarse aggregate, and we have to decide a water cement ratio. So we mix the concrete mix, and then we make 3 test samples, that is should be tested at 3 days, 7 days, and 28 days. Normally we test at 28 days. We take out the sample and we crush it in UTM machine, that is universal testing machine. So compressive testing machine, we have to find out the ultimate failure load. So ultimate failure load divided by the surface area, that is 150 mm cross 150 mm area, gives us the compressive strength, that is determined in Newton per mm square. Then the most important properties of concrete are curing of concrete. So cement concrete has to be kept wet for few days after its placement to ensure complete setting and hardening of cement. So curing is the term used for the job of keeping the fresh concrete wet till the desired purpose of ensuring complete setting and hardening of cement in the concrete is achieved. So what is the objective of curing? The first and the foremost object of curing is to provide enough quantity of water for cement to hydrate and set completely. Another object of curing is to maintain a proper temperature in and around the concrete during the setting process, so that the hydration process is complete and the strength that comes from box compound is favorable for us, and the ultimate strength should be given by it mix. This is because both freezing and drying temperature hamper the process of setting of cement in normal manner. So if we keep wet by curing, the sample will be favorable to us. Then what are the methods of curing? So methods of curing are: first, water curing. This is the most common method of curing. By this method, the surface of concrete is continuously kept wet. Water curing can be done in four ways. First, by spraying water at regular interval. This is done for curing vertical surface of concrete, for example columns or vertical walls. Second, wet curing by putting jute bags, sawdust, wet sand, canvas, or similar water absorbed material. As you can see in the road surface, we keep jute bags by putting it wet. Then impounding water in earthen or sandy bunds in square over the floor slab. Sandy bunds or earthen bunds means made, that we make square shapes made or burns at the surface and impound water or store water into it. Then immersing precast concrete element in curing tank. Then second important method is membrane curing. Membrane curing means you have to cover that surface so that it cannot be exposed to the surface or the evaporation is negligible for that. So for this you have to cover the surface by polythene or waterproof papers. Then next is temperature curing. The hydration can also be accelerated by maintaining the wetness at the same time increasing the temperature. So it is done by steam curing at ordinary pressure, steam curing at high pressure, then hot water curing, then curing by infrared radiation. This is used in AAC block, autoclave aerated concrete blocks, temperature curing. Then miscellaneous methods of curing are application of calcium chloride on the surface will retain the moisture and help in curing. Then sealing of bottom and side form will prevent moisture evaporation. So I think we have cleared this topic. So thank you.